Hello friends, today we are going to start with chemical reactions of carboxylic acids. This is the final part of this chapter, that is aldehydes, ketones and carboxylic acids. Just to recall, what are carboxylic acids? The compounds which contain C double bond OH group are called carboxylic acid, that is RCOOH. There are 7-8 reactions. The first reaction is action of SOCl2. We have already seen in the alcohol chapter. Same reaction is repeated here. When carboxylic acid, I have taken the example of acetic acid, CH3COH. Acetic acid is also called ethanoic acid. When this ethanoic acid or acetic acid is reacted with thionyl chloride, SOCl2 means thionyl chloride, acetyl chloride is formed, that is CH3 C double bond OCl, and the byproduct formed is HCl plus sulfur dioxide gas, SO2 gas. The main product is acetyl chloride. The second reaction of carboxylic acid is action of phosphorus trichloride, PCl3. When three molecules of carboxylic acids are heated with PCl3, again the product formed is acetyl chloride, that is CH3 C double bond OCl plus phosphorus acid H3PO3 is formed. The reaction should be balanced, therefore 3 molecules of CH3COH plus PCl3 gives 3 molecules of acetyl chloride plus H3PO3. Third reaction is action of PCl5. When acetic acid is heated with phosphorus pentachloride, again the product formed is acetyl chloride, that is CH3 C double bond OCl plus hydrochloric acid plus POCl3. You can see in this three reaction, either the reaction with thionyl chloride or phosphorus trichloride or phosphorus pentachloride, the product is same, that is acetyl chloride, but the byproduct is different. In the first reaction, sulfur dioxide and HCl is formed. In the second reaction, phosphorus acid, that is H3PO3 is formed. And in the third reaction, HCl plus POCl3, phosphonyl chloride, is formed. So, three reactions, they are similar to that of reactions with alcohol. In alcohol, also the same type of reaction takes place. Instead of acetic acid, if methanoic acid is used or if propanoic acid is used, only alkyl group will be changed. Instead of CH3COH, if C2H5COH is used, the product will be C2H5COCl. Same way, in the action of PCl3 also, instead of CH3COH, if C2H5COH, that is propanoic acid, is used, the product will be C2H5COCl. So, in the exam, instead of CH3COOH, any carboxylic acid might be asked. So you have to write according to the reactant, product is also changed. Now fourth reaction is acidic character of carboxylic acid. Why acid is used in front of carboxylic? Because carboxylic acid shows acidic nature. You can see in the example RCOH plus H2O. Whenever carboxylic acid is dissolved in water, it donates proton or it gives H plus ion. H plus ion means proton. And therefore, you have already seen the definition of acid and base in 11th chapter. Any compound which gives proton when dissolved in water is called acid, or the substance which gives H plus ion when dissolved in water is called acid. So carboxylic acid, whenever they are dissolved in water, when their aqueous solutions are prepared, the OH group dissociates and H plus ion is eliminated. So you can see in the example CH3CO minus plus H3O plus. H3O plus is formed by accepting proton from carboxylic acid, and therefore carboxylic acid are acidic in nature. If question is asked, explain the acidic nature of carboxylic acid or explain the acidic character of carboxylic acid, you have to write this reaction, and the explanation is when aqueous solution of carboxylic acid is dissolved in water, it gives H plus ion and therefore it is acidic in nature. Now the next reaction is action of ammonia. This reaction is called amide formation reaction. When acetic acid is reacted with ammonia, it is reversible reaction. Addition of NH3 takes place and forms CH3COONH4 plus ion. This ion is called ammonium acetate ion. And when ammonium acetate is heated, the two hydrogen atom from NH4 and one oxygen from C double bond O group gets eliminated. Water molecule is eliminated and CH3 C double bond O NH2 is formed. It is called acetamide or it is simply called amide. If the general reaction is written RCOH plus NH3, it gives RCOONH4 plus. RCONH4 means ammonium carboxylate ion, and when this ammonium carboxylate is heated, amide is formed, that is RC double bond ONH2 is formed. I have given example here. Instead of acetic acid, if propanoic acid is used, only change is instead of CH3, C2H5 group is involved. Therefore C2H5COH plus NH3 gives C2H5CONH4 plus, and C2H5CONH4 plus when heated it gives C2H5CONH2. Propanamide is formed. So this is action of ammonia or amide formation reaction. Similarly, action of phosphorus pentoxide P2O5. This reaction is called anhydride formation reaction. When two molecules of carboxylic acid or acetic acid are heated in the presence of P2O5, the water molecule gets eliminated. So this reaction is called anhydride formation, or it is also called dehydration reaction. The hydrogen from first carboxylic acid and OH from second carboxylic acid, they get eliminated and two molecules linked together to form CH3CO OCOCH3. This is called acetic anhydride reaction. So the first action of ammonia is called amide formation reaction, and action of P2O5 is called anhydride formation reaction. And the last two reaction of carboxylic acid is, first reaction is action of NaOH. This reaction is called decarboxylation reaction. Whenever carboxylic acid or sodium salt of carboxylic acid RCOONA plus NaOH in the presence of copper oxide CO, the hydrogen from NaOH gets eliminated and the remaining part combined to form Na2CO3, and hydrogen mixed with alkyl group to form RH, that is alkane is formed. For example, you can clearly understand with the help of example CH3COONA plus NaOH, it gives CH4, that is hydrogen from NaOH gets added in CH3 group and therefore it forms CH4 and Na2CO3 is formed plus alkane. This reaction is called decarboxylation because COO group is eliminated. CO2 group from carboxylic acid gets eliminated and removal of CO2 group is called decarboxylation reaction. Therefore, this reaction is called decarboxylation reaction. And the last reaction is reduction of carboxylic acid. So this for reduction, when carboxylic acid is reacted with nascent hydrogen from lithium aluminum hydride LiAlH4, the COO group is converted into CH2 group. Therefore, the product form is RCH2OH and H2 is formed. In this reaction, C double bond O group is converted into CH2 group. We have seen already in aldehyde ketone in Clemenson's reduction or for in Wolff-Kishner reaction, carbonyl group is converted into methylene group. Same reaction takes place here. The carbonyl group is converted into CH2 group and it forms alcohol RCH2H. For example, when acetic acid is reacted with nascent hydrogen in the presence of lithium aluminum hydride, CH3CH2OH plus H2 is formed, that is ethyl alcohol is formed. So these are the seven important chemical reactions of carboxylic acid. In this chapter we have seen the introduction of aldehyde ketone carboxylic acid, then nomenclature of aldehyde ketone carboxylic acid, then methods of preparation of aldehyde ketone carboxylic acid. Then we have seen detailed reactions of aldehydes and ketone, in which we have studied aldol condensation, Cannizzaro reaction, Clemenson's reduction, Wolff-Kishner reduction, and today we have seen the 7 chemical reactions of carboxylic acid. So here we will conclude our third chapter, that is aldehyde, ketone and carboxylic acid. Thank you.